Assalamualaikum. My name is Siti Rozana binti Yahya. Okay, I'm from code CS143 from UIT M. Shah Alam. I want to explain today about the application of differentiation related rate. Okay, what is a differentiation? Differentiation in calculus is a method of finding the derivative of function and also a process in mathematics where we find the rate of the changes based on one of its variable. For example, is the rate changes of displacement with respect to time called velocity. Application differentiation also will be found in science and engineering. How do you do differentiation in math? Suppose we have two variables, x and y. Then the rate of changes of x with respect to y is denoted as dy over dx. The general expression of the derivative of a function is f prime equal to dy over dx, where y is fx is any function. Reason why we are using differentiation: determine the maximum and minimum value of particular function, to allow us to find rate of changes, help us to calculate and predict something with more precise and more accurate. Application of differentiation in our daily life: to determine the speed or distance covers such as miles per hour or kilometer per hour. Check the temperature variation. Calculate profit or loss in business. What is the related rate? Related rate problem involve two or more variables that change at the same time but possibility at different rate. They usually involve writing an equation relating the two variables and taking the derivative of equation with respect to the time. What is a related rate objective? To find the rate of changes of one quantity, know the rate of changes of other quantities. Related rate of changes. For example, a spherical ball is being filled with air. Both the radius and the volume of the ball are increased. Arguably, the rate of changes in the volume V is related to the rate of the changes in radius R. In this case, dv over dt and dr over dt are related rate because V is related to R. Problem statement. Step 1 is identify the rate of changes that are known and the rate of changes that is to be found. 2. Construct a formula or equation that related the variable in step 1. 3. Derivative both sides of the equation. Question 1. A cone is a 30 cm tall and has a radius of 5 cm. Initially, it is full of water, but the water level falls at a consistent rate of 1 cm per second. At what rate is the water draining from the cone? So we know the cone fully is water, but the water is draining. So if we draw a picture, we look something like this lah. You see our picture is have a radius 5 cm. The height is 30 cm and the consistent rate is 1 cm. So from the given information for the size of the cylinder and the rate in which the water draining, what is the rate consistent of height? So okay, we can see lah the water level is going to changes per second. That means the height is also going to change per second. So from the information given, so us can get R is 5 cm, h is 30 cm. So dh over dt is negative 1 cm per second. So why the reason why the rate of changes of height negative? Because water level is decreasing. So also noted, we noted lah the rate of changes of is consistent. So we call is it of a rate consistent. So that so from the asking rate in this case is asking for the rate which the water is draining from the cone. So in other words, we can they are can see lah the rate of changes of the volume of the water. So asking lah for the rate they asking for the rate of changes of the water. So can we write the dv over dt? So we don't know lah the dv over dt. So we deal about the volume and the cone. So we can use the volume of cone is a v equal to 1 over 3 pi r square over h. Over h plus 1 over 3 pi r2 h. So taking the derivative of volume of cone, we need to use a product rule and chain rule. So first we can separate v 1 over 3 pi r2 and h. So now we can do the product rule and change rule. dv over dt bracket 1 over 2 pi r square bracket dh over dt plus 1 over 3 pi times 2r times dr over dt bracket h. So equal to 1 over 3 pi times r2 times dh over dt plus 2 over 3 pi times r times dr over dt times h. So this problem here, we don't know exactly for dr over dt. So we have to figure out. So if we need to figure out lah about the So we going back to the original equation is v over 1 over 3 pi r square h. So we can find out the to get rid of the variable r. Then we can avoid getting dr over dt when we take the derivative. So by expressing r in term of h, we can do by using similar triangle. We can see over the diagram. I already the graph lah. Sorry for the diagram. So r, you can see r, we can see 5, we can see height, and we can see 30. So we notice two triangle lah. We can two triangle create from this drawing. So two triangle is similar, then the ratio must be same as well. So r over h equal to 5 over 13. So isolate r equal to h over 6. So we just create equation for r terms of h using similar triangle. So we need to take the equation and substitute r in the volume of the cone equation. So we can see the v over 1 over 3 pi bracket h over 6 time bracket square h equal to 1 over 1 over 8 pi h. This is for h3. So now taking the derivative of this will give it us dv over dt 3 over equal 3 over 108 pi h square times dh over dt. So equal to 1 over 36 pi h square times dh over dt. So we need to differentiation equation given. So dv over dt 1 over 36 pi h we already get 30. So put the value for h, bracket 30 close the bracket, square times dh over dt we know is -1. So put the -1 times -1. So equal to negative 900 pi over 36. So we can calculate equal to negative 25 pi centimeter square, or centimeter per cube, centimeter per cube over second. So the rate of which the water draining from the cone is 25 pi centimeter square pula, centimeter cube per second. So we know lah, if the value is negative, we need put to the answer is a positive answer only. So for question 2, if we blow air into a balloon of a spherical shape at a rate of 1000 centimeter per cube per second, and we rate the radius and of the balloons change when the radius is 7 cm. Also compute the rate of which of the surface area changes. So we can the solution is the volume of the balloon of radius r is a v equal to 4 over 3 pi r square. Pi r cube. So we are given dv over dt equal to 100, and we need to find dr over dt when r is 7. So now dv over dt is 3 times 4 over 3 pi r square times dr over dt. So substitute r equal to 7 and dv over dt is 1000. We get 1000 equal to 4 pi times 49 times dr over dt. So dr over dt equal to 1000 over 4 times 49 times pi equal to 250 and 49 pi. Such the surface area S of the balloon is S equal to 4 pi r square. Therefore, ds over dt is 8 pi times r times dr over dt. So substitute lah, dr over dt is 250 over 49 pi, and r 7 we can get the ds over dt is 9 ds over dt is 8 pi times 7 times 250 over 49 pi equal to 2000 over 7. So the rate of changes of radius is 215 over 49 pi centimeter per second, and the rate of change of surface area is 2000 over 7 centimeter cube over centimeter cube per second. No centimeter per cube. This is centimeter for centimeter square. This is centimeter square per second. Sorry, I confuse the centimeters per cube and the centimeter per second. But this is centimeter per second. Centimeters square only. Conclusion, we can get a differentiation is a something that will be very useful and in each aspect of our daily life, because many problem can be solved in this concept in mathematics, which is a differentiation. So we should explore more about the application of differentiation in real life, especially in different situations, such as astronomy, science, physical, business, engineering, and others. Thank you.